So we're going to play with the same idea. And so notice these two problems right here, the same function, one's going to positive infinity, one's going to negative infinity. Okay, so again, whoops, we're going to take the highest power term from the numerator and denominator. So let x is going to infinity. So I get root 9x squared over 2x. So limit as x goes to infinity. So this is 3, because it's root 9, right? And then root x squared. Oh, there it is again, right? So you know that root x squared is the absolute value of x. So I get 3 times the absolute value of x over 2x. Okay, so I need to show the step that I know since I'm going to positive infinity, I get a positive number out. So I get itself out. So I get 3x over 2x. X's cancel. I get 3/2. So again, this step, all of these steps are necessary to show, so I see that you understand that you're using the definition of absolute value. This one here, x is going to negative infinity. So I'll get 3 root x squared. I can take liberties because I just did it up here, right? 2x. I did not skip any of the crucial steps. So limit as x goes to negative infinity. 3 absolute value of x over 2x. Okay, this is where it's a little bit tricky. So I'm going to be taking the absolute value of a negative number. And what the absolute value rule says is to take the opposite of the negative number. So there's a negative number in there. So I'm going to take the opposite of that negative number. And that's going to make it positive. And then I have over 2x. I can cancel the x's. So I get negative 3/2. So what I just did is I took the limit as x goes to positive and negative infinity of this same function. And what that's really doing is finding the horizontal asymptotes. So I just found the horizontal asymptotes for this function. And so how you state horizontal asymptotes is y equal negative 3/2 or y equal positive 3/2. And yes, you could write it as plus or minus 3/2, but it's always y equals when you're finding horizontal asymptotes. Okay, so let's just recap. You know how to find vertical asymptotes, and this is how you find horizontal asymptotes. You take the limit, right, towards, so it's called end behavior, right? You've done this before in pre-calculus, I know. Okay. You could cross horizontal asymptotes because this is just what's happening as you're heading out to infinity or negative infinity. Vertical asymptotes, remember, you have to cancel first because those make holes. They're not vertical asymptotes. And once you simplify, the function never crosses its vertical asymptotes, and that's where the denominator is 0. Remember, you get vertical asymptotes when you get numerator is a number and the denominator is 0. Okay, so here we go. Let's do this one. And I'm even giving you a hint. Make sure, or a reminder, I should say, make sure you always cancel first. So I can see there's a common factor of x in the numerator. And so I see that this can be x minus 5, x minus 1. And so, oops, I did that wrong, didn't I? So this should be a 1. Okay, so then I'm going to see that this part right here is a difference of squares. X minus 1, x plus 1, x minus 5, x minus 1. Okay, cancel. So x equal 1 is a hole in the graph. I'm not going to draw it, but it's not going to be a vertical asymptote. So our simplified function would be x plus 1, x minus 5. Okay, so I can see that my vertical asymptotes or where the denominator equals 0, so that's 5. And that's how you state vertical asymptotes. It's x equal 5. Okay, so to find the horizontal asymptotes, I'm going to take the limit as x goes to infinity and negative infinity, and I'm allowed to use this simplified version. So I have x times x plus 1 over x minus 5, because I've just done some canceling already is all. So again, taking highest powers, I'd get x squared over x, or that would give me limit as x goes to infinity of x. So that's infinity. Oh, so that just means as you're going off out to infinity, it's just going up forever. It's not a horizontal asymptote. And then if I check out to make sure what's happening going to negative infinity, I'd get the same thing. I'd get x squared over x. And so the limit as x goes to negative infinity of x is negative infinity. So end behavior means way out here, it's just going down forever. So there's no horizontal asymptotes. No horizontal asymptotes.